everyone, welcome back to my math teaching online again. So today in this video, I would like to show you the new topics, which is iteration. And iteration is the second fundamental principle in calculus. We have learned the first principle of the calculus about derivative. And it's not just about derivative. We have learned a lot of stuff involving derivative, application of it on other fields, physics and science. So the iteration part, the second fundamental in calculus, the same as stuff in derivative you learn, they have the application and problem solving, and we went through that with our equilibrium lesson yesterday and a few topics before as well. Today in this lesson, I would like to talk about the iteration. However, the concept of the iteration is very complex, and therefore I don't want to get right into the concept. Sometimes we have to follow the nature of the math universal language. And in that case, I have no choice. I have to show you the concept first before we get into its application. However, if I can get away with the nature flow of the language of math, which is to show you from simple to complex step by step, and you notice that in my course, I will design in progressive level. And these steps are well connected together. And that's my purpose of making the course design. As a teacher, I used to do that in the classroom. And now as a course creators online, with on the pandemic going on, I would like to develop the courses in the way that I understand it should progress from step 1 to step 2 and should be well connected together. So I try my best. Now, be patient with me and forgive me for my talkative, because sometimes I need to emphasize to you that although we have a difficulty in time of crisis right now, with the pandemic going on, but I just found it's natural skill of our survival skill. We come up with a different way of coping with it, and to avoid it disrupt in our education, there's now a lot of online courses to help you, and not just one of individual, the whole world that can get into the internet and watching over YouTube for free education. So as a course creator, I would like to advertise for my courses. So I would like to talk about that. So please forgive me and bear with me a few minutes. Allow me to talk about that. And you will see the privilege of learning online courses. Is different way of learning. It's not the same like tutoring one-on-one, which is very expensive. Some student can afford, some family can afford, some not, right? Course online, not like you learn from textbook. To see now you learn face with face, instruction one-on-one, like a tutoring one-on-one, but a lot more affordable. And 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 if I teaching you, I try the best. I try the best on YouTube. Like even though no student around me, however, it is allow me to see what mistake. So sometimes I have to record 2 or 3 times because I didn't like what I taught before. So now I can say, okay, this is not good. I'm going to get rid of this part, and like make it the best. So online courses are very well developed, and in a sense of the best education right now. Now, I don't know what happened in the next 20 years or 10 years. Maybe we come up with another way of teaching or learning. However, right now, I feel that online courses are accessible, affordable, and the best qualification in education. Because we try to produce our videos in the best way. We are expertise in our area, so we'll be able to um, develop the course and to serve you. Um, and I guess as the educator, we always do that. We always try the best, our best. So in my bias, I believe that this form of education is new to some of students. Um, Now we have online course a long time ago, even though before the pandemic, I guess, but it's not as popular as right now. And I believe this is very standard way of learning and teaching. So allow me to talk a little bit about that. Sometimes you might not notice. We are given free and we not realize and we don't know to value it. And we have it in our hand, but we might toss it away because we don't know its value. And that's why I want to talk about it before I get into the lesson. So please bear with me. Also, I would like to show you my new domain on my website. I have posted some video in the website. If you don't register to my course to get the whole access to the whole courses because it's too much, you might be interested in one or two videos and some of my, like writing on the website, mymathteaching.ca, and it's very easy to remember. I changed the domain because I am still in the way of figuring out for myself which platform is the best. So I just changed it. The domain is mymathteaching.ca. So if you key in Google and you key in mymathteaching.ca, you will see my website. And as a course creator, sometimes we serve all of you education on YouTube, which is, I believe that it benefits some audience and maybe some not interested in that. However, we work hard and with yours well support us. We appreciate and I think we should support in each other if we want to do something good for our society. Anyway, thanks for watching. And let me get into the lesson today, right now. So today's lesson will be about iteration. I will talk about why it iterates and how it was developed in the next unit. But I would like to put this unit in front because this is totally about the algebra skill, computational skill. It not require a lot of complex concept thinking. So it's straightforward and it's easy. So I want to put it before the complex knowledge you can learn in the next chapter. It will be more difficult and more thinking involved in that. Now, I would like to show you, just give me a second. In order to do the iteration, you need to have in front of you a sheet of formula. And all what you have to do is looking at this formula and try to perform the iteration, right? Now, the first lesson today, I will not get into the method, the technique of iteration, which is like substitution and iteration by parts, but I will focus in general form ideas around the iteration using our previous knowledge in algebra skills we already learned in Math 12, Math 11, blah, blah, blah. Now, the next step, I also want to emphasize about one more step I put in our lesson today is the evaluation of iteration. Like before, we just iterate and iterate the same like we do antiderivative, right? But today we'll go one more step, which is we evaluate our antiderivative as well. And when we evaluate it, we will first do the antiderivative to get the function, right? So let's say you have a notation like this, a iteration from a to b, and this is the function you iterate, right, in general form, then the outcome will be getting back at original function f of b and f of a. So all what you have to do is substitute the numerical value from b here into your original function and substitute the a here into your original function, and then subtract them to find the difference between them. Now, make sure you follow the order, right? After you do iteration, you get the original function, you use f of b minus f of a, not the other way around, right? Because we know that in math, if you say 3 minus 4, it's different from 4 minus 3, right? So therefore, a little notice of that, okay? And so let's get into the first question. How do I iterate this one? Now you see they side by side, no side between, it means they multiply together. So first let's simplify them, multiply them. But before I multiply them, I have to transfer this square root of x to the rational power. So it's become x times with, and I put a dot like a multiply, or I can put in bracket, right? X to the power 1/2, right? This is the power 1, and this square root 2. So when we transform into rational power, the power go on top, the root go at the bottom. So we have x squared times with x to the power 1/2 and dx. Now multiply, it means you add power. So I'm going to add these two power. So I'm saying this will become 2 and 1/2 is 2.5. 2.5 is the same as 5/2. So I'm going to put x 5/2. Okay, and dx. So that's how I simplify them, right? Before I iterate. Now I'm going to iterate or doing antiderivative. And when I do this, this will become, remember the power of antiderivative. If into derivative we take one away, power away. In iteration, we do backward operation, opposite operation. So we add 1 instead of take away 1, right? And down here, this 1 was supposed to be multiplied with the power, but in the iteration or antiderivative, we go backwards, which is opposite direction, opposite operation. So multiply become divide. So we divide like that, and we not multiply. So I just remind you the symbol rules, how we do antiderivative, right? So that's how it looks like. So now I'm going to add 1 into this power, right? And when I add 1 into this, I have to do common denominator, right? So this will become, the power will become x to 7/2. That's the power. However, 1 here have to divide by 7/2 as well. And divide by 7/2 and plus c. Divide by 7/2 means you twist the fraction opposite, like reverse, right? So it's 2/7 x to the power 7/2 plus c. So we're done. That's how we do it. Okay, that's how we do it. So this is our answer. And so that's how it looked like. Okay, so I show you how to do the first question. Now, every question are a little bit different. This one, what should I do? I'm going to separate them first. So I'm going to say this is the same like t, adding with, and t, dt actually, adding with 2 over t. And I'm going to bring the 2 outside, right? Because this is constant, I allow to bring it outside. 1 over t inside dt. Why I do like that? Because it's easy to integrate. I separate them, and that's the rule in integration. The same like the rule in the derivative, we are allowed to separate them, right? By individual, by one. So I separate them like this, and I'm going to integrate the first one, which is, this is power 1, add into 1 is power 2, and 1 divided by 2, t to power 2. That's it for the first one. Now for the second one, it will be the 2 still outside constant, right? We integrate inside 1 over t equal ln t. And you can know that from the formula. 1 over t equal ln t, 1 over x equal ln x when you learn the formula. And you have a formula sheet in front of you when you do this stuff, okay? So it's not so complicated. Okay, so that we done the first one, the second one. Now I go through with you the third one. And what is the third one look like? Each question is slightly different. I'm going to apply the formula. Now, this is the same like you have 2 brackets timed together. And you do 1 by 1. What do you call this? It's foil or something, right? Inside, in or out, whatever you call a foil, right? Method, combination, multiply, distribution. But I'm going to use a formula because the formula is the easiest way. Okay, so this equal a square, the formula, plus 2 times a times b. If you learn quadratic equation already, you should know this, plus b squared. That's the formula. So this formula is, and I still put in iteration, right? A square, which is this one, is 1 square. 1 square is 1, plus 2 times a times b, plus 1 times this, which is 2 square root x. And instead of write as square root x, I don't like it because I have to write in power to be easier to integrate. So I write in rational power, x to power 1/2. That is 2 times a times b, and the last term is b squared. Square of the square root, they undo each other, so it just become an x, right? Because when you square this one, you cancel with the root. That's how it looked like. And dx. So now I'm going to integrate. After I simplify like this, now I'm going to integrate. And how do I integrate it? 1 become x. This will be add to 1 for the power. 1/2 add 1 is 1.5. 1.5 the same like 3/2. So that will be x to the power 3/2. And this 2 have to be divided by 3/2. Now 2 divided by 3/2 the same like 2 times 2/3. And that equals 4/3. So I'm going to change this 1, become 4/3. Okay. So we'll rewrite it. This is 4/3, x to the power 3/2. So now this one we do the same, x we add 1 power, will be x to the power square, but we divide by 2, and then x to the power 2. Plus c. That's how we do antiderivative. That's it. That's all you have to do. Now, let's get into the next question. This next question, you see a little bit different because we have the interest, but also we have to evaluate it after we do iteration. And the interest and the evaluation based on 0 to 1/2 here. So like A here and B here, right? So after we do iteration, we will substitute the numerical value in and we subtract them like this, right? So this is f of A and this is f of B, okay? Now let's do this one first. If you have a formula in front of you, you will see this one equals R psi x. And R psi x equal psi reverse, right? Invert of psi, the inverse of trigonometric function. Psi minus 1 on top. And on your calculator, you see it here, right? So that's how it looks like, the inverse of psi. X plus c. Okay, so now I'm going to put in the value and I'm going to draw a line here. I'm going to put 0 here, 1/2 here to remind me. Okay, so now I'm going to substitute in invert of psi x. I substitute x by 1/2 minus psi inverse of psi 0. Now this requires you to remember a little bit background information of trigonometry. If we have the 1/2 here ratio, it means you have an angle go like this. And this is 1 because psi and your angle theta here, psi equal 1 over hypotenuse, and hypotenuse is 2, 1/2. What angle is that? This angle is 30-degree angle. And 30-degree angle in radian equal pi/6. So now we evaluate this because that's how it tells us. So psi inverse of psi 1/2 ratio 1/2 equal pi/6 minus psi of 0 inverse of psi of 0. What is that? What angle is that? We have a 0 degree here, the same like 360 degree, the same like 2 pi at this number line, and we have 1 0. This stands for cos, this stands for psi. So psi of 0 is 0, right here, right? So we know psi of 0, which is in equilibrium section, yesterday you learned 0 minus 0. So what is our answer for this? Our answer for this is just pi/6 minus 0, which is pi/6. And that is our answer for this. Okay, so now I'm going to go to the next question. Somebody remind me that I try to facing the ball without looking at the audience in my teaching. Maybe because I have to write it, right? So, but I try to remind myself, communicate with you, not just staring at the ball all the time. Okay, so let me show you how to do this one. And again, for this one, I'm going to bring the constant outside because anytime we have a constant, that's how we do. It's more easy, right? So I'm going to bring outside, and inside I have 1 on the top, 1 plus square x at the bottom. And why I do like that? Because if you look in your formula sheet, you know that 1 divided by 1 plus x squared is the inverse of 10. It's like R10. And R10 the same like inverse of 10, which is 10 with the minus 1 on top, like that, right? And so that is the formula. But now we do the integration, right? We're not doing the formula. We just do the integration. So 12 still 12. Time with what? 10, inverse of 10, right? 10 minus 1 on top, x. And that's it. But we have to evaluate. See 1, this is square root 3. So 1 square root 3. So draw a line like that and do like that. It reminds me I have to evaluate it. And that's the way we did in math, okay? So we're going to say 12 here. I'm going to open the bracket. Inverse of 10. Okay, let's go back to the trick a little bit again. So we have square root 10 equal opposite over adjacent. So we have an angle look like this. And opposite is square root 3. And adjacent is 1. So this will be 2. Right? If you refer back to Spencer triangle, that's how it looks like. Now this angle equal pi over 3, which is 60 degrees in Spencer triangle. So 60 degrees. So now it's pi over 3. So we know the evaluation of this is pi over 3. But actually, if I go step by step, it should be like this, right? Minus 10 minus 1 square root 3, all of this in bracket, right? So let me borrow a little border from here to finish that question. So after we put in f of b minus f of a like this, right? Then we have, I try to look at you again. So f of square root 3 minus 10 inverse of square root 3 will be equal 12 outside. And we evaluate this angle. We know the inverse of this ratio is our angle pi over 3 minus our angle of that. Okay, sorry, I make one mistake. This is f of b minus f of a. So this should be 1, not square root 3. Sorry about that. So this should be 1, right? F of b minus f of a. So we know f of b is pi over 3, 60 degree angle, and tan of 1. Tan of 1 is the same like sine over cos. And if you have sine over cos the same, then that equals 1. And the only angle you have the same is 45 degree angle. Because this side equals this side, and this is 45 degree, and this is 45 degree. So tan of 1 is 45 degree, which is pi over 4. That's how it looks like. Okay. Now I'm going to multiply by, right? Now the same line, I'm going to cancel the 12 down here, up here with the 3 down here. So 10 cancel with 3, give me 4 pi, right? 12 divided by 3 is 4. 12 also cancel with 4, give me 3, right? So I get 4 pi minus 3 pi. And 4 pi minus 3 pi is pi. So the answer is very simple. Pi is our answer for the 5th question. So today I would like to end the video today just for 5 questions today I show you. Now, I believe that my math teaching is I go very slow, right? But however, I don't know if some of you think that I go too fast. I don't think so. But I try to be in intermediate. Anything medium is good. If we go too over on the extreme side, it's not good. In everything, right? Even though in smoking, in drinking, whatever, eating, if we eat too much, it's not good. If we eat too little, it's not good. We try to eat in medium. So I don't know. Anyway, I hope you understand and you enjoy my teaching. Um, I will see you in the next video. I will talk about the iteration again. And please forgive me if I'm so talkative. I missed the so chat. So this is a chance for me to talk to my audience, which is invisible audience. You can see me, I cannot see you. But anyway, I would like to talk a little bit about the online course because I am developing it and I would like to advertise for my course. I want you guys to help me to advertise my course as well so that everybody will buy my course. So that I can have more energy and produce more course again to you, to honor you, to your children maybe. Okay, so thanks for watching. Bye for now, everyone. Stay tuned for our next lesson. We're still in the iteration. And then we will get into the concept of what iteration means and how it was developed. That will be a lot more interesting. So bear with me. Bye for now.